All right, so we're going to talk about domain and range. You might want to pause the video to copy down the definitions if I go too fast. So the domain and range, we've been seeing it a lot. You've been seeing it for years now, but we're going to like nail it down. Okay, we're going to get it this time. And you should have done really well in the Desmos activities by finding the domain and range of graphs. But on the back, I'm going to do some examples of finding the domain and range of functions. Okay, so domain, set of all possible inputs or x values. It's like, think of a number. Can you plug that number in? All right, so, and then the answer is yes or no based on what type of function. The range are all the set of possible outputs or y values. All right, I do not want to go over this because I think you guys know how to do it yourself. So you're going to try this later, not during my precious video. Based on the Desmos activity, you should be able to find the domain and range of each. This should be review. Ready? Turn the paper over. Okay. Please pause the video and you're going to copy this down. Okay? So, domain and range is kind of grouped by functions. Domain and range used to be really boring because in Math 1 in 8th grade and 7th grade, all you knew how to graph were lines. So we have a horizontal line or a line with a slope, and the domain and range, the domain is all real x values and the range is all real y values. And you know that the arrows on both sides, meaning they go to negative infinity and positive infinity, so they hit all the y's and all the x's. Okay? Hopefully you got a little intro to domain and range of absolute value and quadratic functions. But do you see how the arrows on the absolute value and the parabola here, do you see how they go to the left and then to the right? Yeah, do you see that? So to the left is going to negative infinity and to the right is going to positive infinity. So they hit every x value. So the domain there is any x value. Another way you can think about it is that can you plug any number you want into absolute value? Yeah, you can. You can plug any number you want. Can you plug any number into a quadratic and square it? Yeah, any number. Positives, negatives, fractions, decimals, any number you want. All right. Range, though, are the outputs, the y values. When you plug numbers into absolute value and quadratics, something interesting happens, right? What happens to every number that you plug into absolute value? It always comes out positive. What happens when you square every number? It comes out positive. So there's y values that won't be included in the ranges here. So if a is positive, what does a parabola or absolute value look like if a is positive? Or we say concave up. Do you agree it's going up like that? So does this function hit y values below the vertex? No, it does not. So the range will only be the y's that are greater than the vertex. So you have to find this vertex point and then go up from there. All right. What if a is negative? Then your graph is facing down like that. So there's no points up here anymore, but it's from the vertex down. So it's all the y's less than the vertex. It looks like my... All right, so the range is limited based on if it opens up or down. Got it? Yes? All right, what about a square root? Can you take the square root of any number? No, you can only take the square root of what? Positive numbers, all right? Otherwise, the answer is imaginary, and we can't graph imaginary. There's no domain, and we'll talk about that in your future. So the domain means whatever's on the inside here, whatever's under the radical, that has to be what? It has to be greater than 0 because it has to be positive. You ready for examples? Okay, so now we have non-graphic examples. You see these are not graphs yet. They're just function equations. You ready? Here we go. What's the domain? So you tell me all the values under the square root have to be positive, correct? They all have to be positive. So what we're saying is that x plus 3 must be greater than 0. Everything under the square root has to be positive. Can you solve that? That's what you went to 8th grade for, right? How do you solve x plus 3 is greater than 0? What do? Subtract 3. So x has to be greater than negative 3. That is your domain. Do we have to do the range too? Yay! Okay. Let's talk about the graph of this function. What would the starting point be? Do you remember that? Like the vertex? So the starting point of our square root, like that, where is it going to begin? Do you remember? You do the opposite of the inside. So x plus 3, what are we going to write down? Minus 3, right? The opposite. And then what number is on the end here? Outside. 0, right? 0. So the y value is 0. In front of the square root is a, the number in front. Is it positive or negative? Positive. So look at our little graph. This is a graph of this. Do you agree? Yeah, it's cute, isn't it? Okay, all the x values are greater than negative 3. What are all these y values? Are they going up or are they going down? They're going up, and they started at 0, so that's our range. So our range is going to be all the y's greater than, oh, we got to go back and talk about 0. Hi. Can you take the square root of 0? What's the square root of 0? 0. So can this be equal to 0? Yes. So we got to go back and fix, edit, edit. Let's go back into our lovely notes here. And the domain has to be greater than or equal to 0. Sorry about that. Okay, let's do a few more examples. Ready? Domain. 4 minus 2x is greater than or equal to 0. Not a lot of room here. That's okay. We're going to try our best. We have to solve this for x. What do we do first? Subtract 4. I'll go to the side. So negative 2x is greater than or equal to negative 4. Then what do we do? Divide by negative 2. Dun dun dun! You should get chills right now because you're doing something funny. What do you have to do when you divide by a negative on an inequality? Do you remember that? You got to flip the sign or switch it. What do you say? Switch or flip? I say flip because it's more fun. It's funner. Get it? Get it? I'm a math teacher. Okay. That's our domain. All the x's have to be less than or equal to 2. Does this graph go up or does it go down? What is in front here? It goes up because of the positive in front. All right. And what number's on outside the square root? What number's on the end outside? 0. So it's actually, again, all the y's are greater than or equal to 0. That's our range. All right, you try number 3. Because it's exactly like 1 and 2. I think you can do it. You try. Do, 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 do. Okay, I'll pause. All right, did you try it or you just waited for me? Here we go. 3x plus 1 is greater than or equal. That's an equal, greater than or equal. Now I'm wasting precious video time. Okay, step 1. Subtract the 1. Do you switch the sign on this example? Why not? There's a negative. It's the number you're dividing by. So the number we're dividing by is positive. So we keep it, and that's the domain. What did we just find? The domain. So x is greater than or equal to 1/3. It's kind of boring on the range here, right? They're all positive, so they all go up, and there's no y value. So our range is the same for all 3 of these. Okay, last 2, you ready? These are different functions. Do these functions look the same as these 3? No. What type of function is this? What's it called? It's a quadratic function. Yes, so it graphs a, what's this called? Parabola. And you agree that the number in front is negative. So if a is less than 0, then we agree that the parabola is concave down. We need to know that in order to do the correct range. Okay, what's our domain? Gosh, I wish I had notes on this. Oh wait, I do. So the domain of a quadratic function, what's the domain of every quadratic function? All real x values. So you could put this or you could put that. This or that. Domain, you want to be fancy and put negative infinity to infinity because you just learned that. You want to show that off. Fantastic. Okay, so the range, gosh, what do our notes say about the range? If a is less than 0, then the range will be all the y's less than the vertex. So we need the vertex, yeah? Have we found the vertex yet here? No, but we know how to do that. What do we do to find a vertex? We do the opposite of the inside, and we keep the outside. So the vertex point, I'm going to write it right on my little graph here. What's our vertex point? What's it going to be? -3, then what? +4. Okay, which one is the y value? The 4. So when we go to range, we're done with domain. When we go to range, we don't want to talk about -3. We want to use the y value. And we're going to say the y's. Now, what are all the y's? Are they above the 4 or are they below the 4? So we're going to say y is less than or equal to 4. Same thing here. You ready? Let's wrap this up. Is a positive or negative? So what does that tell you? Concave up. I'm actually not sure if we're allowed to use the word concavity with the absolute value. Where is the vertex point? Vertex point, reviewing it, review, every day. +4, what's the y value? -3. Okay. Domain. Look at your notes. What's the domain of absolute value? All real x. And the range. Okay. Since it opens up, are all the y's going to be greater than or less than? Greater than, and what's our y value we're going to use? -3. So all the y's are greater than or equal to -3. All right, really good job, domain and range, on functions without a graph. Did you get all these notes? What are you going to do? You're going to fill these in, and then we have a practice to do next. Thanks for watching.